Online, am I audible?
Yes, I can hear you. Thank you.
Okay. What are we discussing yesterday? Sorry? Uh-huh. Mm-hmm. So we're done with VLAN. Okay. We just stopped from one VLAN to another VLAN communication. Now we'll try to make the communication between them. Okay. Till now we were trying like the two VLANs can't communicate with each other. But today we'll see how we can make the communication if it is required. Okay. Let's suppose like again I'll take the same scenario what I have taken when I was explaining about the VLAN. Okay. I said like I have HR at this corner, IT, then sales. Okay. This time I'll put a manager here because he's really important. Yeah. So I have created some what do you call partitions here. That's nothing but our VLAN. Okay. So everybody should talk with manager, right? If I try to stop talking with a manager, then how is going to manage the team, right? Yes. So that's the reason what I'm gonna do. I'm gonna make only this HR department, IT department, and sales department. They can talk to the manager. Okay. But they should not talk with each other. That's what. Okay. Understood. So this is what the reason behind inter-VLAN routing. Inter-VLAN routing. Okay. So not exactly like this. I'll tell you like how the two VLANs, even though they are being in a different VLAN, how they can able to communicate with each other. Okay. For that, we have some three methods. Actually, they'll say two methods. Okay. But the initial method, what they used to use, now they are not using this one. What is that? The first one is a legacy method. And second one is a ROAS. And third one is a SVI. Okay. Legacy method means what? The old method that we used to use for inter-VLAN routing just to make the communication between the VLANs. And then we have router on a stick. What is this ROA stands for? Router on a stick. And then SVI stands for switch virtual interface. Okay. Here in this case, in these two cases, we are going to use a router. Okay. In this case, we are going to use a L3 switch. Yes. Understood. So what exactly this inter-VLAN routing is? It's a process of enabling communication between the devices which are in the different VLAN. Okay. So this typically required in network using VLANs for segmentation. Where we use this one? Wherever we segmented the whole broadcast domain to some multiple. Okay. If you want to make the communication between them, in this case, we use this inter-VLAN routing with the help of what? With the help of L3 devices. Which are the L3 devices we have? We have router and a layer 3 switch. Okay. And these are the three methods I said. One is the legacy method. Second one is what? Using sub interfaces method. That's nothing but the router on a stick. I'll tell you why they call it as a router on a stick. Next, we have SVI, switch virtual interface. Okay. In the first one, using legacy method, again, router interfaces, we'll say that one. So that will go to the your favorite CPT. So what happens in a legacy method? Let's suppose like we have router, okay, and inside that network, let's suppose we have some three VLANs like VLAN 10, VLAN 20, and VLAN 30. Okay, and this switch is configured with those VLANs and the switch is connected to the same router. Okay. But in this case, in the legacy method, what we can do, what we have to do, we have to connect each, for separate cable for each and every VLAN. Okay. For 10, we have to connect a cable. For 20, we have to connect a separate cable. For 30, we have to connect a separate cable. Okay. So each and every cable, they used to carry the separate VLAN data. So what do you think these interfaces will be? They'll be access or trunk? Obviously, they have to be access port, because on this interface, I'm going to use give the 10 data, and here 20, and here 30. Okay. So this is how we are configuring this one. Understood? So you know that VLAN is what? It's a layer 2 protocol. So router is nothing to do that one with that VLAN. Okay. So what it is concerned with? It is concerned with only IP address. So obviously we are going to give the different IP addresses here. Different network. Okay. When you are dealing with a router, then obviously you have to give the different network. Understood? Let's suppose like if you are given here 10.0 network. Okay. Here I'll go 20.0 network. And here I'll give 30.0 network. Okay. Like this we have to configure. Done. Now what happens in this router on a stick? So what is the disadvantage of having this legacy method according to you? What is the one disadvantage, the biggest disadvantage? I said for every VLAN we have to connect a separate cable here. Let's suppose now we are having only 3 VLANs. Let's suppose we have 10 VLANs. What to do? We have to connect separate 10 cables between these two. Okay, so that's the reason this is a biggest disadvantage. Okay. So, but in a smaller network, you can use this one, where if you are having very less number of VLANs, in that case, you can use this legacy method, but it will not work in a complex network where you have more than 10 VLANs, more than that. Okay, that is not possible to, connect separate cables between these two devices like router and a switch. Yes, it is possible, but what about the other network where they are going to go? Okay, so that's the reason it is not feasible in the complex network. Okay, it is only okay in the small network where we have only few VLANs. Okay, so to overcome this one, we have this method that is called as what? A router on a stick. What is this router on a stick? Here will be having only one cable between this router and a switch, where it will be carrying multiple VLANs. Okay, then according to you, this interface should be, obviously it should be trunk port. Why? Because it has to carry VLAN 10, 20, 30 through the same cable. But the thing is like, we are going to use sub interfaces. That means we are not going to use this physical interface. Okay, we are going to use a sub interface of this one, of this router. Okay, let's suppose like we have a interface called 0/1. So inside this 0/1, we have some sub interfaces like 0/1.10, 1.20, 1.30. Okay, we are not going to use what? A physical interface, but we are going to use a logical interface. Understood? So now why it is called a router on a stick? Because the switch and a router, they are connected via only one link. Okay, how it looks like? This router is standing on a stick. Okay, so that's the reason they call it as a router on a stick method. And in SVI, we'll see it later. Don't worry. Okay. So take this 29 double on router. Okay. Yesterday I have given one scenario to practice. What about that one? Did somebody find the solution? Nobody? Nobody tried it? Yes? I will try. You will try. Okay. You tried. Did you get it? Which connection?
To switch one, to switch one, the switch, to switch zero, the switch one. Full connect, fast connect,
It was connected.
complete हो रहा था। सर मैंने बात कैसे कहा था कि मैंने VLAN 10 का एक्सेस दिया पर आपने उसको HR और ये नहीं किया
कहाँ पे?
PC 10 के जो फास्ट कनेक्ट 0.0 VLAN 10 का एक्सेस दिया तो हमको ट्रांसपेरेंट में मैनुअली VLAN क्रिएट करना पड़ा क्योंकि उसमें उसके पास वो पता नहीं है कि कैसे वो आएगा जैसे सर्वर को फॉरवर्ड कर देगा तो वो सेव नहीं करता है इसके लिए हमको मैनुअली क्लियर कर देते वो ट्रैफिक को
फर्स्ट वाले को.
वो देने के बाद वो
No, I have created VLANs on both the routers. I mean on server and that forwarded that to client. Yes, Mr. Narendra.
Sir, we need to create a VLAN in the transparent switch. VLAN 10. It's executing for me.
Okay. You tried it?
Yes, yes.
Okay.
No, it's pinging both the PCs.
It's pinging. Good.
VLAN 10 need to be created in transparent.
Exactly. What you have to do? Let's suppose we have again the same scenario. First, second, and third switch. Okay. On that first one is what? It's a server. Okay. And second is a transparent. So third one is a client. Okay. And on this one I had created a lot of IP address, VLANs. Okay. I mean, I connected 50 VLANs, then I could have, created VLAN 10 also, right? So I've connected one PC here. So I made this into VLAN 10. Okay. And I've connected one more PC. This also I made into VLAN 10. Okay. These two switches know who is VLAN 10. Okay. But transparent mode doesn't know who is VLAN 10. Why? Because it is taking the data from the server mode and it is just passing it. It is not saving it. Okay. But whenever the actual traffic comes, once you already know that these trunk ports, what? They'll tag the data packet. They'll tag what? Data packet. What the trunk port will do? They'll tag and untag the data packets. What you have seen in the native VLAN. What you have seen in the native VLAN? On the trunking ports, tagging and untagging of the VLANs will takes place. Okay. So whenever this data of first PC, which is of VLAN 10, which will be leaving this port, which will be carrying what? VLAN 10. Okay. But once this goes to the transparent mode, transparent switch, okay, it sees its VLAN database. Do I have any VLAN 10? No. Then how should I forward this data towards the next? Because I can't untag it, and while leaving, I can't tag it because I don't know who is VLAN 10. So that's the reason it will not forward that VLAN 10 data. So that data will be dropped here only. Understood? Clear? Yeah, this is also having a VLAN 10 because it is getting it from the server. But this transparent mode doesn't have any VLAN 10 information. Okay, yes, you have to add a VLAN 10 into this transparent mode, then only they will forward the packet towards the next device. Am I clear? Sure. Just try it and give me the result tomorrow. Okay. What will get the slash value? Fast. 16. Good.
20.
20. 20. Sure. Are you sure? Why?
Because network is free. Class C.
Class?
Class C.
Is it class A IP address?
Class C IP address.
Is it?
Yeah.
Sure. Okay, this is what the configuration what you have to do. Okay. Now we'll start with the PC. What network I have to use here? What network I have given here? Network 192, 168.1.1 I'll take. Okay. Can I take 0? No, right? Why? It's a network address. Next, by default, it took 255.255.255.0. This is what the default subnet mask of this class C. And then we have default gateway. Okay, I'll tell you it later. Okay, does anybody know what is exactly this default gateway is? Online?
Exit interface.
Exit interface. For what?
To connect to the other network.
Exactly like what happens in the switch devices. Okay. Till now, what we were seeing, we were not even touching this default gateway. We were just assigning the IP address and the subnet mask was automatically it was taking. Yes. Now, when it comes to router, we have to give the default gateway. What do you mean by this one? We are saying this PC that if you want to talk with any other network other than this 192.168.1.0 network, if you want to talk with any other network, just like 2.0, 3.0, you have to go and meet your default gateway. Okay, because as you already know that router makes the communication between the network. Between what? Different network. And router does know where is this 192.168.2.0 network is connected, 192.168.3.0 network is connected. Okay, because that will be there on that interface. Okay, so just to forward this data from one network to another network, we have to go and meet what? Our router. It is what? Just a gateway. So if I ask you to go out of this lab, how will you go? You'll break this glass and you'll go? No. You have a proper door, right? You have a gate. Okay. So if you want to meet outside world, you have to go through the same path. Understood? So this is also same. What do you mean by default gateway? If you want to meet the different network, yes, you have to go to your default gateway, and your default gateway is nothing but what? It's the router. Okay, where it will be maintaining the routing table, and with the help of that routing table, it will guide you how to reach the destination. Okay, understood? So this is what the default gateway is. Am I clear? So here in this case, we have to give the default gateway to each and every end device. End device means what? These PCs. So on this default gateway, I'm going to give 192.168.1.10. You can give any number, and this is my favorite, so that's the reason I'm giving this one. Okay. So close this one. Don't worry, we'll go with, we'll go for DNS server also, but later, not now. Let's assign the IP address to second PC as well. So that should be 192.168.2.1. 192.168. 2.10. Okay. Three dot one is the IP address. 192.168.3.10 is the gateway. Okay, done. Now we'll go and configure this switch now. What you have to configure in the switch? What you have to configure in switch?
VLAN.
We have to configure the VLANs here. Okay, and other than that, sorry. Oh. Interface fast Ethernet 0/1. I'm not going to create the automatically, it will do. Okay. So switch port mode access and switch port access VLAN 10. Okay. Exit interface fast Ethernet 0/2 and switch port mode access. Okay, and switch port access VLAN 20. Okay, and then exit interface fast Ethernet 0/3 and the switch port mode access and switch port access VLAN 30. Okay, so I have created some 3 VLANs. Yes, and even added the interfaces to the VLAN. Okay, I hope how it is. I hope you know that. Yes. Other than this, we have to add other interfaces also into the VLAN. What are those? 0/4, 0/5, and 0/6, because they have to be what? The trunk port as well. Because the first 0/4 will carry the VLAN 10 data. Second will carry the VLAN 20 data, that is the 0/5, and 0/6 is going to carry the VLAN 30 data. Okay. So exit interface path Ethernet 0/4. Okay, that is switch port mode access and switch port access VLAN 10. Exit from this one, interface path Ethernet 0/5 is there. Next switch port mode access and then switch port access VLAN 20. Exit from this one and interface path Ethernet 0/6. Switch port mode access. Okay, and then switch port access VLAN. That's done. Done. So let us check that we done it correctly or not. Do show VLAN. There you go. /1 and /4, they are added into VLAN 10, and /2 and /5, they are added into VLAN 20, and /3 and /6 are added into VLAN 30. Okay, done. So you want to change the name also. Okay, VLAN 10, the name will be like HR. VLAN 20, name will be like IT. And then VLAN 30, name is like done. Exit, do show VLAN, there it goes. ICHA, IT, and sales. Yeah, did. Now the switch configuration is done. Now we'll go to the router configuration. Okay, we'll be having the same 3 modes here also in router CLI. What are the 3 modes? User execution, privilege mode, and then global configuration mode. Now we are into user execution mode. So enable config D. Now we are into global configuration mode. Okay. Now let's go to the interface. That is interface gigabit Ethernet. Gigabit Ethernet 0/0. Okay. Here, how to assign the IP address? It is really simple. What you have to do? You have to say IP address. Okay. If I say question mark, it will be asking like 2 things. You want to give it manually, or you want me to choose it from the DHCP server. We don't have any DHCP server currently in my network, so that's the reason I'll go with a static configuration. Okay, so what IP address I have to give here? 192.168.1.10. Okay, after this it will ask for what? Subnet mask. What will be the subnet mask? Done. But this is not yet done. We have to enable the interface. Still you can see all these interfaces of router, they are still, it is showing it as a down, red. Okay, so how to enable that one? We have to say no shutdown. Okay, there it goes. It came up, done. So exit from this one, go to the interface, gigabit Ethernet 0/1, and give the IP address, that is 192.168.2.10 with 255.255. Done, and this say no shutdown. Exit from this one, interface gigabit Ethernet 0/2, and the IP address will be 192.168.3.10. Okay, with 255.255.255.0, and then just say no shutdown. That is done. Okay, this is what the configuration is. Any doubt? No doubt. Sure. Okay. Now let's try to ping the other VLAN. Okay. So ping 192.168.2.1. Okay. I'm going to ping the second PC. Understood? Just say enter. First packet got dropped. Why? Huh? First packet got dropped. What's the reason? Why the first packet got dropped? Hmm? You want me to ping it again? Okay. What's the reason, guys? Why? Every time. See, the first packet every time, if it doesn't know the MAC address of the destination device, okay, what it does, it will try to know the MAC address for the known IP address. Okay, So that's the reason the first packet got dropped. The first packet always get dropped if you are pinging for the first time because of the R. What is R? Address resolution protocol, which will help you to map known IP address to the MAC addresses. Clear? Sure? Okay. Now if you try to ping the third one, 3.1. First packet got dropped. Yes, and the remaining 3 got reply. Again, it is because of what? R packet. Okay, and if you ping it again, that will be continuous. See? Understood? So this is what the legacy method. Okay, so what is disadvantage I said? Here every VLAN need what? A separate cable between the router and a switch. So if you have multiple, more number of VLANs, then we have to connect multiple cables between the router and a switch. So that's what the biggest disadvantage of having this legacy method of inter-VLAN routing. Then next, we'll go for the second one. That is stick what? A router on a stick. Yeah, online. Any question with the first method? Mr. Bosu, Narendra, Pradesh, and Vaishnav.
No, I'm okay. Thank you.
I'll just take the same data. Okay. I've assigned the IP address to the PC devices. Next, go to the switch to configure that one. Let's take this a bit side. Yeah. CLI and interface fast Ethernet 0/1, and this should be switch port more access, and then switch port access VLAN. Okay, exit interface fast Ethernet 2 should be switch port mode access, switch port access VLAN 20. Okay, exit interface fast Ethernet 3 and switch port mode access, and then it should be accessing VLAN. Done. I created 3 VLANs and I added the interfaces as well. Okay. Or you want to change the name of that one? No need, right? Okay, great. Now the switch configuration is done. We'll go to router. Okay. Sorry. Oh, you are awake. That's what I was thinking. Nobody's talking about that. J/4. We have to make it what? Transport. Switch port mode. Done. Sure. Good. Enable config T interface pattern adjust as 0. Here just say no shutdown and no IP address, because I'm not going to give any address on the physical interface, but I want to give it a sub interfaces. Okay, so that sub interface is like interface gigabit Ethernet 0/0.10. Okay, if I say question mark here, this many interfaces I can create. Can you count it? Can you count? It's approximately 4.3 billion. Okay, so that many number of sub interfaces I can create on a single physical interface. Okay, now I'll go with 0.10. 10 means what? Why I'm taking 10? Because I want to send this VLAN 10 traffic through the same sub interface. Just to make you understand, I'm going to take it as a 10. Okay, just say enter. What it says? Interface gigabit 0/0.10 just change state to up. But I didn't even say no shutdown. How it said it like that? Did I say no shutdown? I did. When? On this sub interface. Sub interface is out now. So I think. How? Because I said it on physical interface. Okay. So I'm creating sub interfaces in the same physical interface. So I don't need to give any no shutdown command here. Okay. So after this, you can see here, it will come into sub interface. Okay. Now here we have to give the encapsulation. Okay. We have to say this particular sub interface that you have to encapsulate what? Only VLAN 10 data. Okay. How we can do that one? We can see the configuration here. Okay. What is that? Encapsulate .1q 10. You already know that what is encapsulation and .1q. Know it, right? We discussed about this one in where? Native VLAN. Okay. We have two methods, right? For encapsulation or tagging. Which are those? ISL and .1q method. So which we prefer? Always .1q. Okay. Why?
It supports different vendors.
Come again?
It supports different vendors.
And
Minimum overhead.
it carries a minimum overhead because the ISL adds 30 bytes of 26 bytes of header and 4 bytes of trailer. Okay, so that is increasing the overhead on the switch. Okay, every time. And you already know that this ISL tag even native VLAN data also. Okay, so that's the reason always we go for what? .1Q. IEEE 802.1Q. Okay, now just go with the encapsulation. If I say question mark, here also it is giving you only one option, that is .1Q. .1Q, if I say question mark, it is asking me for what? Which VLAN traffic you want to allow on this particular interface, sub interface, that is 10. Done. And then you have to give the IP address on this sub interface. 192.168.1.10. Yes. Yes. And 255.255.255.0. Because this is the gateway for that PC1. Okay. Say exit from this one and go to the other interface 0/0.20. Why 20? This is for the VLAN 20. Okay, just say enter, and then you can see automatically the interface got up. Next, we have to give what? Encapsulation again, .1Q 20. And then I have to give the IP address, that is 192.168.2.10 with 255.255.255.0. Then exit and interface gigabit Ethernet 0/0.30 for 30 VLAN, and we have to say encapsulate .1Q 30. Clear? Now we have to give the IP address 192.168.3.10 with 255.255.255.0. Clear? Done? Great. Now if you check the routing table here, exit, do show IP route, there it goes. It says that on 0/0.10, I have assigned with an IP address called 192.168.1.0 network /value 24. I already said you, router keeps only network addresses. You can see here, network addresses. Yeah, it keeps both. I mean, like 1.0 also, 1.10 also. 1.0 means what? Which network is connected here with a /value 24. But here it is 32 again. What do you mean by that one? 192.168.1.10 with a /value 32. What do you mean by that one? I know the CIDR value. Why it is 32? Because this is the host address. This is locally assigned on that particular interface. And this is what? The network address of that one. Network address, host address, broadcast address. Remember? This is called network address. This is called host address. Okay, that's the reason here it is having /24, here it is having /32. /32 means what? Whatever the IP address you have, that all belongs to what? One particular IP address. Okay, there you are not going to change anything because manually you have given them. Understood? So it is happening everywhere. I mean, for all the network. 2.0 and 2.10 with a /value 32. So like this. Okay. If you check the IP configuration, you can see here on actual interface, gigabit Ethernet 0/0, IP is unassigned, but the status is what? Up, and even protocol, line protocol is also up. But where we have assigned the IP addresses? On the sub interfaces of this 0/0, like 0.10, 0.20, and 0.30. Okay, these are the 3 sub interfaces we have created on 0/0. Am I clear? Sure. Okay, now check the connectivity between the different VLAN. The ping 192.168.2.1. Is it? Again, the first packet is gifted to R, okay, and remaining are getting the reply. Okay, if you want to check with the 3.1, again the first packet gifted to R and the remaining are getting the reply. Am I clear? Is the router on a stick is clear? Sure? Okay. Online, any question? Online, please respond.
No, I'm okay.
Good to go, sir.
Yeah. Now I'll go with the layer 3 switch. And I hope you also know that like this layer 3 switch is also called as what? Multi-layer switch.
Actually, the 192.168.2 and 192.168.3 will communicate to the not one.
I didn't get you.
Okay. हमने आईटी अब बना अलग अलग बनाया है VLAN तो दोनों को पिंग कर दिया पहला
ये दोनों को कराना
आपस में इन दोनों को आपस में नहीं होगा
between these two.
यस
Yeah, they will.
यू नॉट इन दैट और 3.2 जैसे आपने समझा और सिर्फ क्लाइंट से बात
I was again. You have to do one thing. It's a task for you, everyone. Okay, yeah, we can do that. It's just thing. I was just showing you like how we can make the inter-VLAN routing, how we can make the communication between the VLANs. Okay. यहाँ पे आपने देखा, sorry, what you have done here? What you have done here? You've given all VLAN access. Okay. I mean, you allowed VLAN 10 also, VLAN 30 also, VLAN 20 also. Sorry, yeah, 20 also. But what I said, you want to make it communication only with the manager. Let's suppose he is on VLAN 20. Okay, think how to do that one. But that should be done on all the department, on HR, on IT and sales also. And here also. Okay, how to do that one? You already know, and this is very easy. Okay, here I have allowed every VLAN, but there I have to what? Allow only that particular VLAN. Understood? Here I've shown you just how to make the communication between the VLANs. And even I said you initially, I'm not going to do the exact thing. I'll be showing you everything, like how to make the communication. This is again task for you. Okay, do it. And even I given the solution also. I'll steal the same data from this scenario. Murali, can we assign IP address to a switch port? Can we assign IP address to a switch port? Yes or no?
No.
Sorry? Don't know? Good. No. Yes or no? No. Sure? Okay. No.
Sir, I think it is very good. Yes, because these are routing also and switching also.
Okay. That is smart answer. Next. No. Yes. Yes. So what do you mean by this one? We can? Okay. No.
Sir, what was the task in the previous topology?
Okay. One second. 192.168.3.1. 192.168.3.10. Okay, good. Task was like, now I have shown you here what all the PCs are able to talk with each other, even though they are being in what? Different VLANs. Now what I want only this PC, let's suppose like this is a manager PC. This is what the manager PC. Only this should be communicating with the other, and these two should not communicate with each other. This is what the task is. Now we can able to see that both are pinging. Okay, here also both are pinging. I don't want that one. Okay, this is what the task
Yes.
is.
Yes,
Okay.
got it.
Yeah. You can try it in all the three methods. Yeah. Somebody said yes.
Yes, sir. Yes, sir. Got it.
No, here. Can we assign the IP address, Mr. Narendra, to a switch port?
For layer 3, it is compatible with IP address also. In layer 2 switch, we can't able to assign address.
Now I'm in layer 3. Do you think I'm able
Yes, we
to
can.
assign?
Yes, sir.
Okay, I'll try that one for your understanding. If I say IP address, it is not taking. It's not taking. If you want me
So
to give
routing need to be enabled.
routing need to be enabled. Okay. How to enable the routing? Sorry.
Router is not. Come on.
Router?
Come on. Router are not enabled.
Hey, it is. I said IP routing. It is enabled.
Not showing switch near.
Switch near.
राउटर के स्विच जो लिखा है उसका जो राउटर लिख के आता है
अरे नहीं नहीं. No.
No.
That is a host name. You can change it. Okay. It will not change the name. Done. Yes, Mr. Narendra. Even I enabled the routing, still it is not taking the IP address. You can see here. If you want me to type fully, I can do that 192.168.1.0, sorry, 1.10 with 255.255.255.0. It feels like I don't know who is this IP address. Because inside it is what? It's a space. Okay. For that, what we have to do? We have to assign the IP address. Can you see at the end? At the end, there is a VLAN. Okay. So that means we can assign IP address to VLAN also. Can you see that? VLAN 1, north side, IP address and IP version 6 address also. Okay. If you are not able to do it on the switch interface, you can able to do it on VLAN interface. Clear? So now we are going to forward all the data packets to that VLANs. So virtually we are creating a interfaces with the help of this VLANs in the switch virtual interface. Clear? So first create some VLANs here. Exit and just say VLAN 10. If you want to give the name, it will be HR, and VLAN 20. The name will be IT, and then VLAN 30. The name will be like it's done. Exit. Now what do we have to do? We have to include those interfaces to the VLANs. Okay. And they should be what? They should be what? You can see here the configuration if you want. They should be access port. Okay, this is what the configuration. Don't worry, I'll record this also for your reference. I don't have any configuration for the legacy method. Okay, this is very simple. What you have to do? What you have to do in the legacy method? You have to assign the IP addresses, you have to create the VLANs, and you have to make all the ports of the switch should be what? Access port, and that's done. And after that, you have to go to the router and you have to assign the IP addresses, and that's it. Okay, and this is what the router on a stick configuration is. What you have to do here? You have to create some sub interfaces with the encapsulation method that is called .1q. Okay, and there only you have to mention which VLAN address we have to allow. Okay, I mean VLAN traffic. Next we have the switch virtual interface. Initially you have to create the VLANs. Okay, and then you have to assign those interfaces to the VLANs, and then you have to create, assign the IP addresses to the VLAN interfaces. That is very simple. Let's go to this switch and interface fast Ethernet at 0/1, and this should be switch port mode access and then accessing VLAN 10. Done. Exit. Interface fast Ethernet 0/2, switch port mode access and then switch port access VLAN 20. Done. And next is what? Interface first and 0/3 and then switch port mode access and then switch port access VLAN first. Done. Is it clear? Yes? Okay. Now let's exit, and if you want to see, do show VLAN, there it goes. You can able to see 10, 20, 30 like HR, IT and sales, and the /1, /2, /3, they are included in the VLANs respective. Okay, done. Now what you have to do? We have to assign the IP addresses on the VLAN interfaces. So if I say VLAN interface, if I say question mark, there I think I have shown you. Yes, there is a something called VLAN. Okay, so that will allow you to assign the IP address. VLAN 10 this time. Okay, because this is for VLAN 10. So here you can see, here also I didn't say any no shutdown, but automatically the port got up because it's a logical one. It's a virtual one. Okay. So IP address 192.168.1.10 with 255.255.255.0. Okay. Exit. Then interface VLAN 20. Okay. On this one, I have to give the IP address as 192.168.2.10. Okay, with the 255, the 255.255.0, and say exit interface path Ethernet 0/3, and then this one exit, that's what interface VLAN 30, sorry, and then the IP address will be like 192.168.3.10 with the 255.255.255.0. That's it. Exit. Okay, if you want to check the routing table, do show IP route. It says like I have connected with 3 routes, that is on what? VLAN interfaces. VLAN 10, VLAN 20, VLAN 30. Okay, what are those interfaces? Sorry, network addresses 1.0, 2.0 and 3.0. They are directly connected. Okay, done. And let us go to the PC devices and try to ping the different VLANs. So just say ping 192.168.2.1. Pinging 3.1. First packet gifted to ARP and remaining negating the reply. Okay. Understood all the 3? Yes. First one legacy, second one router on stick, and third one is a switch virtual interface. Am I clear? Everyone? Great. Online? Online?
Yes, sir.
Okay. So this is about the Inter-VLAN routing. I will go with EtherChannel. What exactly this EtherChannel is now? So this ether channel is called as what? It has multiple name. Ether channel. Okay. Port channel and link aggregation. Okay. What do you mean by aggregation? What do you mean by aggregation? Come again? Connection. We have two switches. And this a word comes that is redundancy. What do you mean by this one? Backup. Okay. So redundancy means what? It's a backup. I mean multiple paths between the devices. Okay. For example, this fails, then it will go to the second and third, and the first and second fails, then it will go to the third. Okay. But whenever you connect multiple paths or multiple cables between the switches, there is a one protocol called STP will comes into the act. What is STP? Did somebody heard? Spanning tree protocol. What does that do? You must be knowing, right? You don't? Said you completed. You don't remember or read? Is anybody online? Mr. Bosu, Narendra, Mr. Pradesh. Have you heard about spanning tree protocol?
No.
No.
Okay. So spanning tree protocol, that means what? Let's suppose this switch is generating a broadcast packet. Okay. Just like a R packet or CDP packet or something like that. Yes. So you already know that broadcast packet means what? Obviously, the destination MAC address will be 12 Fs. Okay. What the switch will do? It will check the destination MAC address and it will just send it to everyone. Okay. So like that, it will send it to this interface, and this interface. Okay. Understood. Now this switch to get that packet, what it will say? Again, the destination MAC address what? 12 Fs broadcast MAC address. Again, what it will do? It will send it to everyone. Again, the same loop will be creating between these two switches. Continuous broadcasting of this packet. Okay, so just to stop this one, just to stop the looping process in a layer 2, okay, if they are having multiple paths, okay, so we use a protocol called spanning tree protocol. Okay, but in ether channel, we have the same issue. We have same issue. What is that? Now here we have connected some multiple paths between the switches. Okay, so obviously it is going to create a broadcast storm. Okay, so just to stop this broadcast storm, what we have to go with? We have to go with the STP. Okay, but the condition is like we want to configure this ether channel also. We want to configure ether channel also. In that, what we can do? I mean, what exactly happens? it is going to aggregate all these physical layers into one logical layer. Yes, the physical connectors will be there, the physical cables will be there, but internally they will be aggregated. Aggregated means what? Combined. Okay, that's called what? Ether channel or port channel or link aggregation. Okay, we'll see why we use that one. So why we use this one? So let's suppose like we have, it is a 1 Gbps link. This is also 1 Gbps link. Okay, and this is also 1 Gbps link. Understood? Now, as I already said you, the STP will comes into the act immediately. Then what it will do? It will make these two interfaces as a block. Even though we have multiple paths, okay, just to stop the looping, what it will do? The STP will make two of the interfaces as a block ports. Then that means again, we have only one path. Okay, then you may ask like, then what is the use of these two paths? Yes, there is a use if you don't create the ether channel also. What will happen? If this is getting failed, then the STP immediately make this interface as what? Active. Okay, again this will be into block port. But there's a problem. What is the use of these two Gbps now? We are given the bandwidth there. Yes, even though, I mean, giving this 2 Gbps bandwidth, okay, between the switches, total we are given 3 Gbps bandwidth, but we are using only 1 Gbps because of the STP. Okay, then what is the use of giving this 3 Gbps? So this reason, what we will do, we will just go for the ether channel. What we'll do, we'll just combine all these physical links into one logical link. Okay, by that you can use the entire bandwidth what we are given here. Clear? And this will help for redundancy also. Understood? There it goes, ether channel. It's a technology used to combine multiple physical Ethernet links into a single logical link, just to increase what? The bandwidth, provide the redundancy, and improve the reliability. Okay, as I already said you, it's going to increase what? Bandwidth. It's going to give you redundancy as well. So by this, the performance or reliability will be increased. Okay, in this topology. So it is supposed, yeah, it is supported on both Cisco and non-Cisco devices, which works on both layer 2 and layer 3 devices. Okay, we can aggregate the links on switches also and on routers also. Okay, so but there are some conditions if you want to go for the aggregation or want to create the ether channel or port channel, there are some requirements. Okay, so before that, there is one condition, like we can aggregate up to 8 physical links into one logical link. In a Cisco devices, we can add maximum 8 links, 8 physical links into only one logical link. A non-Cisco, that will be 16. Okay. So these are some requirements for the link aggregation. What is that? The speed must be same. What do you mean by speed now? What do you mean by speed? Yeah, all the cables or ports, okay, what are you using between the switches? They all should be same Ethernet. Okay, so this should be also 1 gigabit Ethernet, this also, and this also. All should be 1 Gbps link speed. Okay, next is what? Duplex must be same. Duplex means what? You can't run half duplex here and you can't run full duplex here. Both either should be half or should be full. Okay, always you will go for the full duplex. Next is what? Ethernet standard must be same. You can't use fast Ethernet here and gigabit Ethernet here. No, either there should be what? Fast Ethernet at the both end or gigabit Ethernet at the both end. Next is what? Trunk encapsulation protocol must be same. What do you mean by this one? trunk encapsulation method. Either they should use ISL at the both end or .1Q, any one of it. Okay, then only the Ether channel will be creating, otherwise it will not. Okay. Now, some features of this Ether channel. First one is what? Bandwidth aggregation. So it's going to combine the bandwidth of multiple physical links into one logical link. Same thing I've shown you in the diagram. What it will do? It's going to combine all those bandwidth like 1 Gbps, 1 Gbps, 1 Gbps, 1 Gbps, and you are going to come whenever you create the Ether channel, that will become what? One logical link. That means we have on that logical link we have how many? 3 Gbps of bandwidth. Okay. Next is redundancy and load balancing. Like if one link fails, then the traffic will be redistributed to across remaining links. That's what called redundancy, right? Next is compatibility, which works with the STP, spanning tree protocol, and prevents the loop by treating one logical links as a single interface. Okay, let's suppose we have 6 links between these two. Just assume. Okay. What I'll do, I'll create these 3 as one link and these 3 as one Ether channel link. Okay. That means the STP will not run on the physical ports or what do you call links. It will run on logical links. That means it will be allowing only one Ether channel and second will be blocked. Understood? So this is how it is really compatible with the STP. It is going to prevent the loops here also, but not on the physical links, but on the logical links. Clear? Next, supports multiple protocol, like works with the PAGP, port aggregation protocol, and second one is the LACP. These are some 2 protocols what we have in the Ether channel. PAGP, port aggregation protocol, and second is a LACP, that is link aggregation control protocol, or even we can do with the static mode also, and we call it as a on mode. Okay. Now we'll see both. I mean, all these 3. Ether channel modes. There are 3 main ways to configure the Ether channel. First one is what? Static Ether channel. Also we call it as a on mode. Here it does not use a negotiation protocol. Negotiation, remember? Negotiation. Where we studied? Dynamic trunking protocol. So here also we have some dynamic Ether channel protocols. Okay. But here in this static one, it doesn't require any kind of negotiation, because that is required only in the PAGP and LACP. But how we create this Ether channel in here? I mean, we have to configure it on both the ends. Manually, you have to configure on both the switches. Then only the link aggregation will be done. Okay. Next is PAGP, port aggregation protocol. Okay. So here, this one is a Cisco proprietary protocol. That means it works only on the Cisco devices. Okay. So here some modes we have. One is a auto mode and second is a desirable mode. Same we have. What is auto? What is auto? It is a it will be waiting for the request from the opposite end. And desirable, it is actively ready for the negotiation to the opposite port. Okay, here also same thing. Auto, it's a passive mode which will wait for the PAGP packets. Okay, request packet. Next is desirable, which is actively negotiates with the other side. Okay, so these are the 2 modes we have in the PAGP. And next one is what? LACP, Link Aggregation Control Protocol. It's an open standard. It's what? Open standard. That means it will work on both Cisco and non-Cisco devices, which is standardized with 802.1.3 AD. Okay, here also we have some two modes, active and passive. So where passive is equivalent to the auto and active is equivalent to the desirable. Where passive will be waiting for the LACP packets from the other end, and active is nothing but what? Actively sends an LACP packets to negotiate with the other protocol. Sorry, other ports. Okay, I mean opposite port. Clear? I will go for the configuration. It's very small. You can see the color of these interfaces. Okay, so initially they'll take some 30 to 50 seconds to get on. Okay, because the STP will be running there. Okay, so I can't wait up to that. I'll just fast forward it. You can see that. Even if I forward it, okay, still two interfaces are down. I mean, they are in, not exactly down, they are in block state. Why? Because the STP is running there. Okay, but what I want those two also should be actively participating in the transmission of the data. Okay, with the help of that ether channel. Yes. You can see there. I'm just showing you the spanning tree. Okay, 0/2 and 0/3 of the switch 2, they are in block state. Okay, only one that is in forwarding state. That means only the first 0/1 is able to forward the data, not this /2 and the /3. But I want those two should be also into forwarding state. Okay, so for that, what I have to do? I have to configure with the port channel. Enable and config key. I have to go with the range command. I mean, I have to take all of the interfaces at the same time. Okay, because I want to combine in a same logical link. So how to do that? Interface range fast Ethernet 0/1 2 3. Okay, so I'm into if range. Yes. Now we have to say channel group. Okay, if I say question mark, it will ask me for what? A group number. Okay, that will be 1 I'll give. And then it will be asking you mode. Mode, if I say question mark again, it will be giving some different modes. What are those? Active for LACP, auto for PAGP, desirable for again PAGP, on for enabling ether channel manually, and passive again it's for the LACP. Now I want to show you only with the on mode. Okay, done. Now it says that instead of saying interface 0/1, 0/2, 0/3 got up, it says that port channel 1 got up. You can see here the port channel 1 just changed state to up. Okay, but still it is showing like this. What's the reason? Again, the opposite end is not yet what do you call negotiation with that one. Okay, so for that reason I have to go and configure the same thing on the second switch as well. Okay, so config T again interface range fast Ethernet 0/1 2 3, and then you have to say channel group 1, you have to keep it in the same group. Okay, and after that the mode will be on. Done. You can see that all the ports are up now. Okay, if you want to check and just say show ether channel port channel. Okay, what are the number of ports here? 3. Okay, EC states it's happened because of the on. Okay, after that I'll show you like summary. Yeah, there it goes. Summary it is. Okay, all these 3 interfaces are added into this port channel 1. You can see here. What is the channel number group? Sorry, channel group number, that is 1, and the number of aggregation, that is also 1. On this particular switch, we just aggregated only 1 logical link. Okay, if you want to add more, you can add more there. Okay, there again the group number will be changes, and then this number of aggregation also get changes. Okay, now if you check it here and just say show ether channel summary, here also it will show you the same thing. There is only 1 and aggregation also 1, and all these 3 interfaces are added into here. Okay, now what the spanning tree says? Now what the spanning tree says? Before it was saying like path Ethernet 0/1, 0/2, 0/3. Okay, where 0/2 and 0/3 were in a block state. But now it is showing only 1 interface. That is port channel 1, that is group number 1. Okay, that is into forwarding state. Am I clear? Sure. This is with the help of what? A manual configuration. Now we'll go for PAGP. Again, you can see that STP worked. Okay, and 2 interfaces got into block state. Okay, so just open the first switch and try to configure with the PAGP. Enable config tree interface range path Ethernet 0/1, 2, 3. Okay, here the channel group will be like 1 again, and the mode will be, which mode should I keep here? So here also by default auto will be there. Okay, so let's take the auto only. Okay, and it says like down up. If I fast forward again, it is working on the STP only. That means ether channel not created. Okay, so let's go and go with the same channel group 1. Something wrong? Yeah. Channel group 1, and the mode will be desirable. Okay, that's it. other end. If it's range faster than 0/123, okay. Here I have to give the channel number live, then only it will be able to participate into that channel. Okay. So channel group 1 and the mode will be auto this side. Okay, done. There you go. Okay, happen. Yeah, it will take some time. You can see here, port channel 1 is changes state to up. So if you want to check here, show either channel port channel, you can see there all happened because of the desirable at this end. Okay, and how many ports are added here? Okay, and if it's check the summary, it's happened because of a PAGP. Okay, and how many aggregators are there? Only one, because we are aggregated only one logical link here. Yes. You can check with desirable, auto we have already seen. Okay. And the next one is like LSCP. HTTP worked. Okay, you can see here. This time the switch 1 is having 2 block ports. Clear? Slept? Then interface range for Ethernet 0/123. Okay, here the channel group will be like 1, and this time it is a active. Sorry, mode active. Okay, done. And on the second switch, I have to create the same thing. So enable config interface range for Ethernet 0/123. Okay, here it will be like channel group 1, and the mode will be, again, can I make it as active? Yeah, I can do that. Okay, there you go. Created one. Yes, created. Okay, can check it here if you want. There it is. Port channel 1 is just changed here to up. So just make it as, just show either channel, port channel. Okay, it happened because of the LSC, because we are using active and passive. Yeah, both end I'm using active only. Okay, just to show you that. And if you check with the summary, you can able to see how many interfaces are connected here. Again, with the help of LSCP, these 3 interfaces are made into only one logical link. Clear? This is what about the on mode, PAGP, and the LSCP. Okay, now we'll see like what if I connect 3 more interfaces to this one. I said, right? The STP works with logical. Now the STP is working here. Okay. Let's create one more channel. So config C interface range fast Ethernet 0 slash what was that? 4 to 6. Okay. Here the channel group will be like 2. Okay, and the mode will be active. Okay, you want to make it passive. Okay. Passive, done. Let's go to other end and create this exit from this one, interface range of fast Ethernet 0 slash 4 to 6, and just give it as like, yeah, channel group 2, and the mode will be active. Okay. What it says? Only the first link is in active state and second is in a block state. If you check it with a pure spanning tree, what it says? Port channel 2 is in block state and port channel 1 is in a forwarding state. That means this HTTP is working with the port channel, not with the actual interfaces. Okay. If you check it other side and just say show spanning tree, there both are into forwarding state. Why both are into forwarding state, that I'll explain it tomorrow. Anyway, we're going to start with the STP. Okay, they will understand what is this forwarding, what is this block state, okay, everything. Okay, understood. So this is how the STP works in the link aggregation or a ether channel. Clear? Am I clear? Online? Any question? Mr. Bosu, Narendra, Pradesh.
I'm okay. I just have to rewatch the video.
Yeah, that's what I was thinking. Like, am I that good? Am I explaining that good that you are not having any question?
No. I have a lot of doubts, but I just want to recheck this. Little bit hard theory.
Yeah.
Yeah.
I hope you are understanding these practical things, right?
Yeah. Practical, I'm okay.
Okay, Mr. Bosu, what about you?
Yeah, fine.
Mr. Narendra?
Yes, sir. Good.
Okay, then. Yeah, we'll end it here today. Okay, anyway, it is 9:46. So tomorrow. Anyway.